So, we will start molecular spectroscopy. Or physics of molecules. So, we have studied the physics of atoms or atomic spectroscopy, and now we will see about the molecules. So, what is molecule? Basically, so atom is defined by bound system of electrons and one nucleus, right. So, basically one nucleus and there are many electrons, one or more electrons. So, they are bound together. So, then it is a atom. Now, molecule is basically a bound system of electrons with more than one nucleus. So, when one nucleus electrons bound with one nucleus, then it is atom. When electrons bound with more than one electron nucleus, then it is molecule. So, for diatomic molecule, so it has basically two nucleus and then electrons bound together with these two nucleus. Okay. So, then it is a molecule. Okay. So, so structure is basically structure of atoms or structure of molecules is basically how these electrons or system of electrons are bound with the nucleus. If one nucleus, so then that is atom. So, that is basically atomic structure. And for more than one electron nucleus, okay. So, then it is a structure of molecules. So, we want to study the structure of molecules, means how system of electrons are bound or arranged with more than one nucleus, right. So, to study the structure of atoms or molecules, basically we take help of electromagnetic radiation. When so these atoms or molecules or matter when interact with electromagnetic radiation, then basically we get the spectra. Okay, spectra of atoms or spectra of molecules. So, studying the spectra of atoms or molecules, after analyzing we get the information about their structure. Okay. So, basically the interaction of electromagnetic waves with matter, when matter is in form of atom or is in form of molecules, okay, will tell us about the structure of atoms or molecules. So, one should have knowledge of this atomic interaction with atom and molecules of electromagnetic radiation. So, next let us see the division of electromagnetic radiation in terms of wavelength, in terms of frequency, or in terms of energy. So, we would like to see the spectrum of electromagnetic radiation, basically electromagnetic radiation or waves. Okay. So, spectrum of electromagnetic waves. So, spectrum means this spatial distribution in terms of wavelength or energy or frequency. So, that is basically called the spectra or spectrum. So, in case of electromagnetic waves, what is the spatial distribution of electromagnetic waves, that I will show you. So, here you can see that electromagnetic radiation and their source, means what are the source of this electromagnetic radiation. So, here just I have taken scale. So, this is the frequency scale. Okay. So, this it is in hertz. So, 3 into 10 to the power 6, 10 to the power 8, 10, 12. Okay. So, this is the frequency scale. Next, just below this wavelength scale. So, 100 meter, 1 meter, 1 centimeter, 0.1 millimeter, 1 micrometer, 10 nanometer, 0.1 nanometer, and this is 1 picometer. Okay. So, wave number, in terms of wave number, you are familiar with the wave number. So, in terms of wave number, this is the scale. So, 10 to the power minus 4, 10 to the power minus 2, 10 to the power 0, 10 to the power 2, 4, 6, etc. It's say it is in centimeter inverse, and energy, it is in joule per mole. So, just the scale is 10 to the power minus 3, 10 to the power minus 1, 10 to the power 1, 10 to the power 3, 5, 7, etc. Okay. So, this way just I have taken scale. Now, as per just I can yes, electromagnetic radiation in different range of frequency or wavelength or wave number or energy. So, as the higher wavelength means lower frequency, this is the higher wavelength, you see 10 to the power 2 meter and 100 meter, okay, or smaller energy 10 to the power minus 3. Okay. So, here this 100 meter to say this 1 centimeter. So, in this range of radiation, electromagnetic radiation having frequency or wavelength or wave number or energy in this range. So, this called the radio wave or radio frequency, radio wave, electromagnetic wave. Then this next range of frequency or wavelength or wave number or energy. So, this is called this in this range, if electromagnetic wave is in this range, then that is called microwave. Then next range it is called infrared, Then next one is called visible and ultraviolet range. Okay, ultraviolet ray, visible ray means this our light which is visible to us. Okay. So, visible and ultraviolet ray in this range, and X-ray, next range is in this range, that is electromagnetic radiation is called X-ray, and then next range it is called gamma ray. So, gamma ray have the higher frequency or higher energy, of course, then it is lowest wavelength. So, X-ray wavelength in this range is 10 nanometer to 0.1 nanometer, means 1 angstrom. In this range is X-ray. Okay. So, microwave, its wavelength, this range is say 1 centimeter to 0.1 millimeter or 100 micrometer. Okay. So, infrared, that is in this region 0.1 millimeter to 1 micrometer, but sometimes they overlap, but still we can distinguish whether it is microwave or it is infrared, that we can distinguish, although this same wavelength, but we can distinguish them. Similarly, this X-ray and gamma ray, they overlap in this range, okay, but for same frequency or same wavelength. So, it can be X-ray or it can be gamma ray. So, whether we will tell X-ray or gamma ray, so that we can tell only seeing the source of this radiation. What is the source of this radiation? So, source for gamma ray is different than the source for X-ray. So, this is the broad distribution of electromagnetic radiation, and this radiation are called in different name, okay, depending on their frequency or wavelength or energy. So, this lower wavelength is gamma ray, and higher wavelength, highest wavelength is basically radio wave. Okay. So, what are the source? What are the source of this radiation? Radiation of different kind, although all are electromagnetic waves, but they are given different name, basically based on their source, from where it is coming. So, radio wave, what is the source of radio frequency, radio wave? So, source for radio wave is basically here this energy change due to reversal of spin of nucleus. It is the NMR, nuclear yes, magnetic resonance, nuclear magnetic resonance, NMR, ESR, electron spin resonance. So, NMR, ESR, nuclear magnetic resonance, electron spin resonance. So, this is the source of the radio wave, okay. Although it is electromagnetic wave, but it is called radio wave, and the source of this radio wave is basically the energy change due to the reversal of nuclear spin or electron spin. Okay. So, here just this nuclear spin, say it is in this direction. So, if it is changed from this direction to the other direction, so because of the change of this, because of the reversal of this nuclear spin, there will be change of energy. So, that change of energy will come out as a radiation. Similarly, for reversal of the electron spin also, it will give there will be change in energy for these two state, okay. And corresponding energy will come out as a electromagnetic radiation, and that radiation will be called radio frequency, okay, or radio waves. So, then microwave. So, what is the source of microwave? So, source of microwave is basically, here we are telling that rotation of molecules. Rotation of molecule is the source of microwave. So, that is what we will study in this course. Then infrared. So, radiation, electromagnetic radiation in this frequency or wavelength range, so which is called infrared. So, source of infrared is basically vibration of a molecule. Okay. So, this infrared wave we get this due to the vibration of the molecule. So, this also we will study in this course, and then visible and ultraviolet. Okay. So, this radiation comes due to energy change of valence electron of atom or molecule. Okay. So, basically electronic transition in atom or molecule gives this visible and ultraviolet radiation. So, this also we will study. So, in this course basically we will study the rotation of a molecule, vibration of a molecule, and electronic transition in a molecule. Okay. So, so they give different they give electromagnetic radiation of different wavelength or frequency, and they are called microwave, infrared, and visible, ultraviolet, and ultraviolet rays. Okay. So, this basically our subject. So, that we will study in molecular spectroscopy or physics of molecules. So, from there, so this we will know about this, we will know more, and of course, this our next range is X-ray. Source of X-ray is basically the energy change due to the rearrangement of so rearrangement of basically the core electrons, okay, or it is better to tell that source of X-ray is basically energy change of core electrons in atoms or molecules. Okay. So, that the source of X-ray, and source of gamma ray is the energy change due to the rearrangement of nucleus. Okay. So, this is the gamma ray, you know, this nuclear phenomena. So, rearrangement of nucleus means from one nucleus, if it breaks, gives two nucleus. Okay. So, then there will be radiation. So, this basically rearrangement of nucleus gives the change of energy, and that will give gamma ray. Okay. So, so this you know about the radiation, different kind of radiation, radio frequency, microwave, infrared, visible, ultraviolet, X-ray, gamma ray. Okay. All are electromagnetic radiation, and they are more or less their frequency or wavelength distribution is like this. And here additional things I told you about the source of each electromagnetic radiation which has particular name. And why I have discussed this one, because whatever this molecular spectroscopy we are going to study, it is related with the electromagnetic radiation, that is basically microwave, infrared, and visible or ultraviolet range. So, that is what we will study in this course. So now basically we will study we will start our study in molecular spectroscopy, that is basically this what is first we will see you have a molecule, the rotation of a molecule, rotation of a molecule, okay. So this is called rotational spectroscopy or microwave spectroscopy. So rotational spectroscopy, rotational spectroscopy, rotational spectroscopy, rotational spectroscopy, or it is also called microwave spectroscopy. So why it is called microwave spectroscopy, that you understand. So that's why I describe the electromagnetic radiation, range of electromagnetic radiation. So this is also called microwave spectroscopy. Okay. So this microwave, it is called microwave spectroscopy because this microwave, it is electromagnetic radiation, this comes from the rotation of a molecule. So so we have different, so let us see this let us see this let us see these molecules. So let us say this HCl, it is a molecule, it is a diatomic molecule, right. So this, it has one hydrogen and one chlorine, okay. So hydrogen molecule H2, so this is basically hydrogen atom, two hydrogen atom is separated by a distance, okay. So similarly chlorine molecule, so two chlorine they are separate. So this all HCl, H2, Cl2, these are basically molecule, fine. So what is the difference of this molecule? So these all three are diatomic molecule, right. Now HCl, there is a difference in HCl and H2 or Cl2. So HCl basically it has permanent dipole moment, because two charge, different charge are, these two charge are separated with a distance. So equal charge separated by a, not different charge, equal charge separated by a distance, so it form a dipole moment. So it has permanent dipole moment, okay. And this molecule H2 molecule or Cl2 molecule, okay. So this molecule don't have dipole moment, permanent dipole moment, so it has zero dipole moment. So this molecule, then now molecule we differentiate with respect to this, whether they have permanent dipole moment or they do not have permanent dipole moment, okay. So some molecules will have permanent dipole moment, so this is one group, and some molecule will have this zero dipole moment, so this is another group. So now in microwave spectroscopy there, so this is very important for this difference. So basically these molecules which have the permanent dipole moment, so they are called microwave active molecule, and those molecules which are not having permanent dipole moment, they have zero dipole moment. So, that molecule is called basically microwave inactive molecule, okay. Means neither they will emit microwave nor absorb microwave. So, only microwave spectra we can see either emission spectra or absorption spectra, means either the molecule emitting or absorbing electromagnetic radiation or microwave. Okay. So, basically the molecules which are having the permanent dipole moment, that is called microwave active molecules, and only these molecules will give microwave spectra, okay, either emission spectra or absorption spectra, right. So, microwave, why it gives this microwave radiation? Because this, if you see this, a molecule which is having permanent dipole moment, okay. Now, this rotation of this moment of this molecule basically, okay. So, if this is the direction of rotation, this is the molecule, okay. So, its direction of rotation, due to the rotation, its direction, which direction? Direction of dipole will change. So, direction of the dipole is basically from positive charge to negative charge. So, this is the direction of dipole, then it is changing. So, this will be another direction. So, it is rotating, means changing. So, these are different stage we have shown, okay. So, during rotation, so from this position it will rotate, come here in this position, that means its dipole moment was in this direction, now it is in this direction, then this direction, then this direction, then this direction. So, this way changing. So, dipole now, as if this dipole is fluctuating, okay. So, dipole is fluctuating. So, this fluctuation of dipole with time, we can show if we just take the vertical component of the dipole, okay. So, this is in this direction. So, its magnitude is maximum, and but its negative direction. So, this magnitude and this the value. Now, it is rotating. So, it changing, its value changing when it is in this direction. So, vertical component is 0, okay. So, this is 0. So, here again positive direction. So, vertical component is maximum, then again 0, then maximum in negative direction, then again 0. So, as if this is the fluctuation of dipole moment with time. So, this is the periodical variation of this dipole moment due to the rotation of the molecule. That means, rotation of the molecules is basically giving the periodical change of dipole moment, as if this is the. So, if any periodical change of charge dipole moment, so it gives basically radiation, okay. It emits radiation, and this radiation whatever we will get due to the rotation of the molecule, due to the rotation change of the fluctuation of the dipole moment, okay. So, that radiation is basically microwave, okay. So, this this microwave, whether this molecule will emit or it will absorb. When it is absorbed, then we tell the interaction of the interaction with the microwave, okay. So, interaction of microwave with the matter in form of molecule, okay. So, that is basically that absorption or emission whatever or interaction with microwave, that is basically due to the different states, rotational states of the molecule. So, I will stop here. So, we will continue this discussion in next class. Thank you.